G'day. Here's the software that we all need and no one has. When you tell a customer how much they're going to save on the bill, no one knows. And the reason why is because it's a ridiculous computation that only a very powerful spreadsheet can do. A lot of estimators out there are just more for looks than anything, it's substance, but this is the real deal. If you want the real deal, I have to do it myself. So let's get into it. We've got an array here in 3 sections, sub-arrays with different inclines and azimuth. And that is a total of 66 kilowatts there. Here we've got an inverter AC rating currently set to 100, export limit to 100, and some off-peak peak rates rather between these two times, 7 a.m. and 11 p.m. Very typical. Now, over here we have what everybody wants, the results. We've got this is how many kilowatt hours. Yeah, it is kilowatt hours. It's like 18.5 megawatt hours. Off peak 19,000 kilowatt hours. We're not using this, and we have our export. That's export, not yield. Two different things. That's the net after your usage, how much got exported. And as you can see, it's a very low rate. These are actual rates by retailers now. 3.3 cents a kilowatt hour on export. That's ridiculous. What a rip-off. And from this, you could probably build a macro and just start with the actual inverter size. Let's have a look and see if that figure changes at all. Look at that. It changed up there. So there is occasion where that will try to produce and export more than 50 kilowatts. Let's go that again. So we've got 71,688, 71,681, not much. So as you can see, that's why we oversize things. And this has also, I guess, metering usage there, which has a big impact on that figure. So it's very small once you throw in the other factors, which are not done. No one knows this stuff, right? Because they don't have the software. Anyway, we've got it now. Now let's have a look. Let's say the inverter, 50 kilowatt inverter on a 66 kilowatt array, had no export limitation. So we see no figure change up here. Now let's start going back to 40. Once again, the metering has taken its toll on it. Hasn't changed at all because there's so much usage on this site. A lot of usage here. We'll see that soon. It hasn't affected the export limitation at 40. You only start to really make an impact at 30, which of what I'm going to apply for, by the way. As you can see, it's impacted slightly on the export. And let's go down to what they may give us, only 5 kilowatts a phase, and it's more significant on the export. But look what it did to the bill at this measly rate of 3.3 kilowatt hours. 3.3 cents per kilowatt hour. Let's go scale back. Let's go from that to say no limitation at all, and we'll see that price change hardly at all. We've got a $13,048 bill versus a $13,862 bill. So that's the only difference between 15 and 30 actually. Where are we going? Wrong direction. There we go. 15 and 50 export limitation. Not much. It's better for the customer to put in an EV charger. So now we'll look at the rates here. If I go and put, change this time slot, for example, from let's make the peak rate from 0 to 1 a.m. a very tight time frame. And as you can see, there's hardly any peak for the year. Most of it's hit off peak, and there's our export there. Here's our tariffs, of course, and they end up here as sums, as you can see, and the final is here, which adds up the whole lot. Now, that's ridiculous, so let's just go back there to a normal peak rate. Actually, let's go down to 0. Let's wipe them out. And as you can see, our metering is gone, our usage is gone. But if you've got a flat rate, you usually have a step rate, and it's usually something like, let's make it, I don't know, 10. The first 10,000 kilowatt hours in a 3-month period will be at, in this case, it'll be more probably 45 cents or something like that. And then the peak rate goes up after that. So we've split our usage into 32,000 kilowatt hours and 4,700 at rate 2. So that's typical. Let's say we went to rate 1. Look, it doesn't get over 10,000 kilowatt hours of usage a month. It might if we get rid of the arrays. Yes, it does. And we have rate 2 there. So this is what this does, and it does it brilliantly. Let's go back to what the customer is actually paying, which is, and they're paying from 7 a.m. to 11 o'clock at night in peak. There it is. Oh, tell a lie. I want to go and do a cross-reference here. Let's punch in a ridiculous figure for, well, I don't need a ridiculous figure. Now what I need actually is, what do I need? Go back a few steps. No. Go, I'll just get rid of these arrays. What I want to do is a cross-reference here between the addition of all these things here. If we scroll to the right, that and that is our sum formula there, equals that. And that is directly from our metering data page, which is over here. That there is metering from the utility and a sum up there. That's it. So that's how I know that the total for the year is 81.7 megawatts. And that goes in there to cross-reference with this, as after it's been through all of this number crunching, still ends up the same. You need these a lot, these checkers along as you go. There's quite a few of them. You need them, or you'll get your math wrong or your formulas wrong, and you'll be up creek. So here's another checker here. See, that one's checking against there. This one's checking against there. We've got no yield at the moment. Let's go and put our yield back in there. There it is. Let's go and check our yield to make sure it corresponds similarly. Yep. Well, that's got a minus put on it, obviously, because it's feed in. But that's the actual yield there. While we're on this subject, how do I get these figures? How do you know I'm not lying? Surely no one else can do it. How do I do it? Well, obviously, it requires half-hour interval metering and estimates of the yield in each half-hour period from the 3 subarrays. Total. The total is then divided by the number of days in the year. So I have an average of how many kilowatt hours we produced in a half-hour slot. As you can see, they're over here. This is where the sun comes up. Here's midnight, so bad example. Let's scroll along. So we've got our total kilowatt hours for each array, sub-array. We've got the total added up divided by the number of days in the month, and then put a minus on it, as you can see in the formula up there. And then that will become, that gets trimmed again. Oh, here's a good example. We've currently got it set to 50 kilowatts. So there's two situations here, right in the middle of the day at 1 p.m. in the middle of January here. We've got a very small period of time where it is capable of the array producing more than 50 kilowatts, because that's 2 half-hour blocks there. So that's 50. That would add up to over 50 kilowatt hours for 1 hour, which is over 50 kilowatts. So it got trimmed back to 25. Then we've got our meter readings going in here, similarly, with a divide there in that B18, as you can see, days of the month. And that will change according to leap year if necessary, because they're all date formulas. Spreadsheet's great. You can't do this without spreadsheet. And good luck, no one's bothered to do it with code. It's too hard. You've got a team of nerds who can write code, but they don't know anything about solar. And the solar guy doesn't know anything about code. You don't need, I'm a solar guy and I can do spreadsheet, therefore bada bing. It can be done. So, here's our meter readings. And what we want is the net. And they, of course, are in half-hour, averages of half-hour slots. So everything's been added up for the whole month, divided by days of the month, and you get an average figure for that half-hour slot in that particular month. And then we get our net reading simply by a very simple function there, add the two together, we get an export figure here of 12.6 kilowatt hours. Now we've got another one, net with limited export. Now let's crunch that down, like I said, smash that down to 15, and we get different figures. So let's go back to where we were. January is a high yield month in Australia, and where were we? We're in the morning here. We want it 1 p.m. There we go. So we've got our trim back there from the 50 kilowatt inverter, and we also have it here again. We want to export 12.6 kilowatt hours. We can only export 7.5 kilowatt hours in that half hour time frame. Two together makes 15 kilowatts in an hour, 15 kilowatt hours in an hour, which is 15 kilowatts, and there's our limit there. Now we've got some more filters here to filter between import. As you can see, import usage in the morning when the sun's not shining. This quickly changes to, oh look at this. We switch to peak at 7 a.m. Look at this, there, before we start exporting. Look at that, crazy. And then it's cut back to 7.5 kilowatts per half hour slot, or 7.5 kilowatt hours, until the sun go down. And we've got peak usage here till 11 p.m. and then we go off peak. That's January average. So we pull out and we got one for every month of the year. Look at this. You can even see the data forms a graph. Here's winter. Obviously our yields are going to be less in winter, and the sun's going to come up later and go down earlier. And you might say, oh, right, fair enough. You know how to do your spreadsheets and divide up everything. There's some simple tables up here. Otherwise, you'd need ridiculously formulas, but it's very easily laid out in spreadsheet. You've got cells everywhere. Well, use them. Here's basically extracts from that table to the left up here. Now, obviously, to calculate things like where's off-peak and peak, here we go. Well, we've got two rows there already worked out for us, haven't we? But the flat rate had a bit of a formula here. It's like there's the total of off-peak and peak, but with a caveat. What's that? Multiplied by the days of the month, because we want totals here, and bit of and or formulas and whatnot. Here's our what does that do? Rate 1. So that's going to have this data here taken into account, as you can see. And I could have gone and made it, kept going out to the right here with rate 1 month, rate 2 1 month, rate 1 2 months, rate 2 2 months. But who uses it? It gets billed every 2 months. You only get billed either monthly or once every 3 months. So only need 2 figures. So they got done. Right now there's 0 there because there's a few if formulas there. If this, then don't do that sort of thing. And that's why we get the data here and not here at the same time. That's what you'll want. So as I said, imagine writing that in code. Here it's just a simple if formula. Look, here's a if formula up there. Look at that. If this, do that, otherwise do this. Done. Easy peasy. Well, okay, fair enough. You've got that mastered. But what about this yield? That's got to be a load of crap. How can you predict that? Well, I'm glad you asked. We go to our sun tracker. Guess what this is? I'll tell you what this is. Let me pause for a second. This is something I downloaded back in 2013. The NOAA solar calculation spreadsheet from the NOAA. Some big nautical, big-time government organisation over there in the USA. And they've got this spreadsheet full of astronomical trigonometry. Look at that. It's all there, radians and whatnot. And what it does, you punch in the latitude, longitude, time zone, date. And it'll give you 1 day only. There we go, 1 day only. That many rows in 6-minute intervals. And at the end, it'll punch out on a horizontal surface at those particular coordinates, the elevation of the sun and the azimuth from north. As you can see, in this case, the sun is below the horizon through the earth in the southwest. That's where that came from. So I actually started this back in 2013, never bothered with it because I never used it. I was a subcontractor, never bothered. But now I'm doing a commercial job direct to customer myself, and they ask me some questions and now I can answer them without making up lies. Okay, so there's my edition thereof. I've obviously increased the rows out to 1 month because it was getting hectic, and I also increased, of course, to match the interval reading, the time to half-hour segments. So that data goes in there, and at the end of it, we get the elevation and azimuth on a horizontal surface. Here, we won't go into this, but this is some proprietary, my trigonometry in here to work out where the sun will be. Obviously, we don't want figures from the sun being above the horizon, but facing on the back of the panel, according to the incline and azimuth of that array. There's 3 sets of data here, a lot of cranium, stranium. I'm not going to go in there. So how do we proofread it then? Well, let's go and do an array. Go back to this yield page here. And we'll put this first one at 0. 0, 0, that's a horizontal array. We've got this one here, we're going to put it 90 degrees east. At 26 degrees will do. And we'll put this one at 270 degrees west. Okay, so now we have 2 arrays facing back to back, opposite each other. Let's go over to our sun tracker, and here we are back on the sun tracker page. Now, as I said, we've got this set of data here going and going and going and going, and what do you do with these figures that come out the end? I don't know. Gee, it seems complicated. Well, the only way to process it is to go and put every day of the month there and half-hour intervals across the top here, which is where we get our sense made of all these random figures. So here we have the horizontal figures, because we need the horizontal figures as a reference, because our peak sun hours from our Department of Meteorology have figures from horizontal surfaces. These are peak sun hours on a horizontal surface. Now the first array is dead flat. So after it's been through my special trigonometry, I should have exactly the same figures. Let's have a look. Here's our checks right here. 542, that's more of a ratio. That's a summation of all the percentages, if you would, of the sun being at particular angles. Look at this reading here. It's at 0.62 of directly overhead. Similar to what I did with all the metering, add up all the figures for the month, and looks like we've, what have we done here? Yeah, this is ratio. See this? There's the total of all these percentages, and well, what percentage is this particular reading of that? So you have to divide that into this in order to get the percentage of the whole month of that reading multiplied by its peak sun hours, right there. So peak sun hours is that right there, okay, multiplied by the days in the month. Now, there's your peak sun hours. So I needed the percentage of the month that reading was. That's actually peak sun hours, that figure there. That's how you get your peak sun hours. And here's another check. That equals that after it's all said and done. So we got a total of the peak sun hours for the month by multiplying the days of the month by the peak sun hours per day, and it corresponds with the addition of all my results down here of peak sun hours per half-hour interval. Right, fair enough. Now, as I said, that's the horizontal reference. Here is the first array, and it is identical. Look at that. Spreadsheet's pretty good with the decimal points. It keeps going on. It's got exactly the same figure there. Look at that, all the way. The other two, peak sun hours, ratio to horizontal. Okay? Then we can do the same thing again over here. We've got our proportion of the month that half-hour block represents in peak sun hours, and it adds up to the peak sun hours here, which corresponds with our peak sun hours per month. So that's where all that comes from to organise real results, half-hour interval results in peak sun hours out of all that confusion and figures. East and west, same pitch, 90 degrees east, 516. The math is similar there, 198 peak sun hours per month, and it should be extremely similar. It's a very slight difference. We've got 517, 516, so it's virtually the same, 198 peak sun hours per month between east and west. Very, very slight difference. And that's the way you cross-reference your data to make sure it's working properly. So it's like data with massive tables within massive tables within massive tables. So we've got some figures that mean something, but that's only for 1 month. Do you know how big this spreadsheet would be if it was 12 months? It's only 1 month. That's why we need a macro. Now, I'm going to delete the data. Look at that, that was a macro. See, all my data's gone. If I go back to the yield page, I've got no data here for export. Look at that, my export's gone, everything gone. We're back to our usage only, which corresponds, as I said, in the checks and balances, as previously mentioned. Now we're over here at the Sun Tracker. Now we're going to generate yield. Okay. What it does is smash this those massive tables 1 month at a time until it cuts and pastes as unformatted text. Because if it's not text, as soon as I change the month of the year, all the figures are going to change. If there's a formula in there, we don't want formulas in there. We want to cut and paste. So now that we're all done, we've got a new set of figures, and look at that, I pull back, and as you can see, it represents a year worth of data. We've got summer up here, the sun go down early and get up late in winter, and then again it spreads out. You'd get a diamond pattern, not an hourglass pattern in the northern hemisphere. If I punched in the latitude and longitude accordingly, here's the latitude and longitude right here. That's for Melbourne. Now, here I can do it manually as well if I want to change something. Let's go to February. Why February? There's the data for February. It hasn't affected this because this is all text, remember, with the macros, cut and paste. But let's have a look at February. Now, see that? We've got some zeros down the bottom there because we've cut out the 29th, 30th and 31st. Now, watch this. Let's say I change the year to 24, which is a leap year. This is the beauty of spreadsheet because they have date formulas. Now I'm going to change it to February 2024. What do we got? Well, look at that. The 29th is in there. This is brilliant. Look, I can't imagine doing this with code. This should be the engine room behind your presentation. You can have as glossy a presentation you want online with your app. But spreadsheet, I swear, should be the behind the scenes in the engine room. Otherwise, you're going to make it. It's going to be an absolute nightmare. Anyway, so that's that. There's my proof. As you can see, not only is the hourglass data looking good, but you can see here, here's our horizontal array. The sun comes over the horizon 6 a.m. But guess what? The one facing east is already doing 2.2 peak sun hours immediately because it's already tilted 26 degrees east. And the west one doesn't come up until 8:30 a.m. Meanwhile, at the other end of the day, the east goes to bed early, and the sun disappears over the horizon here as represented by the horizontal panel. And here we have the west-facing array still cranking it out when the sun disappears. So there you go. Everything looks good. There's our proof of testing without actually going out and measuring incline and azimuth on a predicted time and latitude and longitude. But for the sake of this video, that's as good as it gets. And as you can see, it's pretty solid data. And thanks to the NOAA astronomical sun tracking spreadsheet. Good luck finding it. I prefer LibreOffice to Excel because Excel has tries to hold your hand, and there's just too much junk going on here too much to learn, too many sub-menus, too much. This is for someone like me, a bit more of a mathematically minded person, don't want no fuss, just get to the meat and potatoes. So anyway, I've generated another lot of data here, and I was concerned because I couldn't work out why horizontal was producing more. Well, hold on, where are we here? Oh, we're in June. This is June. In June, north is going to pretty much do, north at 26 degrees is going to do double horizontal. I was concerned because I left this on December, which was a month where horizontal actually produces more, as you can see, a little bit more, 10% more or so, than 26 degree north. And I was, oh geez, I'm wrong with my math. So it was a very simple mistake to make. So and then I checked my math and there was nothing wrong with it. So I thought I was wrong, but I was mistaken. And in doing so, I expanded out my formula to make sure things were added and multiplied in the right order. And I have blanked out what I'm actually getting the cos of, and sometimes the whole thing altogether. So you can't, sorry about that, it's just intellectual property. And it did work out and matched the formula that I had, all compacted into one cell. And that was the solar incident angle onto the module. And I went through it very thoroughly, including the removal of the figures that would be shining on the back of the panel. That was actually fortunately easy, because when cos goes beyond 90 degrees it creates negative figures, and so that was really handy for that. And just a sneak view, doesn't make any sense to you, of the trigonometry. Did I spell trigonometry wrong there? I did. I've called it trigonometry. Jeez. Anyway, there's a sneak preview of the trigonometry I used, and that's from 11 years ago. So that was really hard to work that out. But once the Poionier process was done, it was easy to revise, because all I did was follow that diagram, and it was pretty hard. It took me all evening, but I got there in the end. So I'm very happy that the figures are what they should be, and that makes me probably the only person who can do this. See you later.